In this video, we're going to look at how to name acids. Acids are compounds that when you put them in water, they dissociate to form an H plus or hydrogen cation and then some anion. So if we bubbled HCl gas into water, the HCl would dissociate or break apart to form an H plus cation and then the chloride anion. If we dissolved HNO3 liquid into water, it would dissociate to give us a hydrogen cation and the nitrate anion. So both of these substances would be considered acids because they dissociate or break apart to form the H plus cation in water. We're going to look at two types of acids here. Binary acids, which are composed of the hydrogen ion paired with a monoatomic anion. Remember that monoatomic anions are negatively charged ions composed of a single atom. So that would be some of these nonmetals over here on the left side. The second type are oxoacids, which contain an H plus ion paired with some polyatomic anion that contains oxygen. So remember your polyatomic anions, and you can see that a lot of these do contain oxygen. In fact, most of them do. So let's start off with binary acids, and let's look at how to write the correct name when we're given the chemical formula. Binary acids will always start with the word hydro. This represents the hydrogen ion. And then they're going to be paired with a monoatomic anion, but instead of calling the anion or ending it in IDE, like chloride, we would change the ending to IC or IC. And then at the end of the name, we end the word acid. So let's look at HCl to illustrate these three steps. HCl, we have the hydrogen ion, which we would represent with the word hydro. And then we had the chloride ion. So instead of chloride, we would change the ending to IC, so hydrochloric. So we would put those together, hydrochloric, and then we would end in the word acid. So hydrochloric acid would be the correct name here. So follow those steps and see if you can name these three binary acids. Pause the video and see how you do. So the first one, we have hydrogen paired with bromide, so hydrobromic acid. We have hydrogen paired with sulfide, so hydrogen sulfuric acid. Hydrogen paired with iodide, so hydroiodic acid would be those names. Now let's look at binary acids and show you how to write the correct chemical formula when we're given the name. Much like with ionic compounds, the sum of the charges on the cation and the anion have to add up to 0. So our cation, of course, is always H plus with acids, so we need to pair the correct number of H pluses to cancel out the charges on our negative anion. Remember how to recognize a binary acid, because again, it will always start with hydro and end in the word acid. Let's look at an example of this. Here we have hydroarsenic acid. So hydro, that tells us that we're going to have the H plus ion. We're going to start with that. And arsenic, that's going to give us the arsenide ion. And arsenide, we need to know that has a -3 charge. So hydrogen's a +1, arsenide is a -3. So we need 3 hydrogen ions in order to balance out our charges. So when we put them together to write the chemical formula, we represent the 3 as a subscript. So H, little 3, AS. That means we have 3 hydrogen ions paired with 1 arsenide ion to give us hydroarsenic acid. So follow those steps and see if you can write the correct chemical formula for the following 3 acids. So hydrofluoric acid, that's going to be HF. Hydrophosphoric acid, phosphide has a -3 charge. Hydrogen is a +1, so we need 3 hydrogens, so H3P. Hydroselenic acid is going to be H2SE. The Se ion has a -2 charge, so we need 2 hydrogens. And again, we recognize that each of these have a monoatomic anion because all the names start with hydro, so those are all binary. So let's look at oxoacids, which use polyatomic anions, and let's look at how to write the correct name when we're given the formula. It's important to recognize which polyatomic anion is involved in this oxoacid because the name of the polyatomic anion determines the name of the oxoacid. If the polyatomic anion ends in ate, like phosphate, sulfate, perchlorate, then the acid name will end in ic or IC. If the polyatomic anion ends in ITE, like sulfite, phosphite, nitrite, then the acid's name will end in OUS. And then we add the word acid to the end of the acid's name. Let's look at an example of this. HNO3. First thing we have to do is recognize that this is an acid. It starts with the hydrogen ion, and it's paired with some anion. This is also an oxoacid because we have a polyatomic anion. So what's the name of our polyatomic anion here? NO3 minus is nitrate. So since our polyatomic anion ends in ATE, our acid will end in IC. So instead of nitrate, we would call this nitric acid. So if your anion ends in ate, your acid will end in ic, so nitric acid. Let's look at a second one. Here we have HNO2. Again, we recognize that this is an acid because it starts with the H plus ion and then ends with here a polyatomic anion, so this is an oxoacid. And our polyatomic anion, we need to recognize, is the nitrite ion. Now our rule tells us if our polyatomic anion ends in ITE, then we change that ending to OUS. So instead of nitrite, we would call this nitrous acid. So let's follow those steps and see if you can name the following oxoacids. Pause the video and see how you do. Okay. So we have to look at the anion, and here we have sulfite. So that means we're going to end in OUS, or sulfurous acid. Here we have sulfate. So sulfate, ATE, we end our acid in IC, sulfuric acid. Here we have chlorate, so this would be chloric acid. And we have chlorite, so this would be chlorous acid. So finally, let's look at how to write the correct chemical formula for an oxoacid when we're given the name. As before with ionic compounds and binary acids, the sum of the charges have to add up to 0. So we need to have an appropriate number of hydrogen ions to balance out the negative charge or charges on our polyatomic anion. So the name of the polyatomic anion, of course, is going to determine the oxoacid. So we kind of work in reverse here. We look at the name of the acid, and if it ends in IC, then we know that our polyatomic anion will end in ate. And if our acid ends in OUS, then that tells us that our polyatomic anion will end in ITE. Let's look at an example here. Let's look at carbonic acid. So carbonic acid, again, we know it must start with a hydrogen ion, and then carbonic. So that tells me that my anion will end in ATE. So that lets me know that my acid is going to be composed of H plus ions, because that's necessary for any acid. Carbonic tells me that this is going to be the carbonate ion. Now let's look at our charges. Hydrogen has a +1, carbonate has a -2. So we're going to need 2 hydrogen ions for every 1 carbonate ion. Now we just put them together and we use subscripts to indicate how many of each atom we have in the compound. So we have 2 hydrogen ions paired with 1 carbonate ion to give us a neutral acid. So follow those steps carefully and see if you can write the formulas for the following 4 oxoacids. Pause the video and see how you do. So phosphoric tells me that we're going to be using the phosphate ion. So phosphate is a -3, so we need 3 hydrogens, so H3PO4. Phosphorus tells me we're going to be using the phosphite ion. Phosphite is PO3 3-, so we need, again, 3 hydrogens, so H3PO3. Chromic acid tells me we need the chromate ion. Chromate is CrO4 2-, so we must have 2 hydrogens paired with that, 2 hydrogen ions. And dichromic acid, again, dichromic means we need dichromate. So the dichromate ion is Cr2O7 2-, so we need 2 hydrogen ions to give us a neutral chemical formula, a neutral acid. So practice these rules and be sure you follow the steps carefully, and be sure you practice as many as you can and get familiar with naming acids.